All right, we're Torgbot Group again. I just wanted to give you a little update on our progress. So personally, I actually bought my own quadcopter because the problem that we found was that a lot of us haven't been able to play with one yet, so we don't know the exact constraints. So I've been able to kind of analyze the different motor, the lift, how it kind of reacts to controls, the battery constraints, a lot of that stuff, and that's been a lot of fun. And then on top of that, I've also compiled a parts list for the aerial robot design that we've come up with, and the budget of that project is probably going to be around $400 to $500. So I think we're making good progress in that aspect. Next week, I think we're just going to come up with a final decision if we want to go and land in air. And now Chris is going to talk to you about the hardware that we're going to implement.
So I've been doing just a little bit of research on the different types of sensors that we can use for collision detection. And some of the options that we've been looking at is multiple sonar sensors, the Xbox Connect, and most recently the one I was researching was the new Intel 3D RealSense, which is basically a two-camera system similar to the Xbox Connect, and using that to detect objects to avoid collision. Now Zach will talk to you about some of the system hardware as well.
Yeah, so I've been researching some development kits that are already out there, and some hobbyists use them, and there's a lot of info on them, but I've been really trying to see how and if we would be able to use the existing technologies and just implement it in our own custom design. And the two development kits I mainly found were ArduPilot and EasyRobot, and we're going to still have to do some more research to see if we can integrate our own custom design into it, because we're still going to need to customize it. And James is going to talk to you a little bit about a different option.
So another option we have is using an open source platform, kind of like a Raspberry Pi, where we can put in our own system like Linux or Windows 10 or something along those lines. Something a little bit more beefier that can handle the operations, not just one operation at a time, but multiple, and still be able to work flawlessly. So running the motors while giving a visual or audio cue at the same time and following the wavepoints. So we're looking into the Raspberry Pi as a good option for this project.